Today we are writing code for finding nearest neighbors using scikit-learn's neighbors package. You will also see how you can plug in your own distance or dissimilarity function to work with scikit-learn's nearest neighbors package. Let us say that we have this data in a 2D array. We convert it to NumPy array. The variable data holds our data. Given a reference vector, which rows of this data are the closest? That is the KNN problem. We will use scikit-learn's nearest neighbors class. I will add NumPy as NP because we use NumPy in our code. For finding k nearest neighbors, we need the data, which we have here. We need a reference vector against which the nearest neighbors will be computed. Here we are using index 2 of the table as our reference vector. So this ref_vec is our reference vector. Given this reference vector and given this data, we want to find k nearest neighbors. Let's say k equals 3. That is, we want to find 3 nearest neighbors. Let us create the nearest neighbors object, where we mention n_neighbors equals k. That is, we want to find k neighbors. That is 3 neighbors. Also, we want to use brute force method. That is, distance should be computed between the reference vector and each row of the table to find the k nearest neighbors. Other options are KD tree or ball tree, which can reduce the computation required for nearest neighbor search. If you have many rows, you may use either KD tree or ball tree. Or you can use auto to tell the nearest neighbors object to automatically select an algorithm. This is a small dataset with only 6 rows. The use of sophisticated algorithms to reduce search time is overkill. So I am going for brute. That is the brute force approach. I am keeping the nearest neighbors object in a variable named NBRS. Very good. But we haven't yet told NBRS object to use this data variable, which has all our 6 rows and 4 columns of data. We call its fit method with the data as the parameter. Now things are set. The model knows the data, the model knows k, the model knows what algorithm to use. I am keeping the model in a variable named fitted. We also use the neighbors method of the fitted model to find the nearest neighbors of the given reference vector ref_vec. Note here that I am putting ref_vec in an array to make the parameter 2D. Even though we have just one vector, the kneighbors function takes a 2D array where each row is a reference vector. In our case, we are finding k nearest neighbors of only one reference vector. The kneighbors function returns distances of the k nearest neighbors and the indices of the k nearest neighbors. Let us print the indices and the distances of those nearest neighbors. Since row index 2 is itself the reference vector, index 2 is the first nearest neighbor. The distance with the first nearest neighbor of the reference vector is 0 because the distance of the reference vector with itself is 0. Row index 0 is the second nearest neighbor and row index 5 is the third nearest neighbor. Note here that row 0 and row 5 are both at a distance 1.73205, so and so forth, from the reference vector. It is likely that row 0 and row 5 are the same. Let us check. Yes, row 0 and row 5 are the same. This is why their distance from the reference vector is the same. If you change k to 4, obviously you will get 4 nearest neighbors. Now you might say, Dr. Hossain, that is very well, but what distance measure is this mechanism using? What are the distances? It's a very good question. These are Euclidean distances. If you do not mention anything, then here it is Euclidean distance. You could use Manhattan distance by using this metric parameter and within quotation writing Manhattan. Running it, you get the 4 nearest neighbors and their Manhattan distances. Now you might say, Dr. Hossain, you taught us different distance and similarity measures before. We wrote our own functions. Is there any way I could use those functions to find k nearest neighbors? I'm happy that you asked this question. Of course, you can use your own distance functions.